Hello and welcome to this video on Sunburn. As many of you should be experiencing summer in the coming months, the probability of sunburn is high. More so after 2 years of lockdowns and restrictions leading to people chafing to experience a summer in the sun. Sunburn is for the most part a very obvious thing. Red skin that can hurt, it becomes swollen, stiff and painful. More extreme cases can cause blisters to develop. Some very extreme cases can even be considered a degree of burn similar to chemical burns. Over time it begins to heal, beginning with the pain receding and redness going away. This leads to the skin peeling and flaking away. The process is exactly like this, but it is also much more complicated. As with many things, it begins with the dose making the poison. In this case, too much sunlight, or more specifically the ultraviolet light in sunlight, can be just a little too much for your body to deal with. The longer this excess exposure occurs, the worse your sunburn will be. When we talk about ultraviolet light, it's specifically the UVB within the ultraviolet light spectrum. This is the most difficult type of light for the ozone layer to absorb, and thereby it's the one that can most easily damage the body. Ultraviolet light is able to excite the bonds between some of the nucleic acid residues called thiamine. This leads to the bond becoming malformed, with two thiamines linking to each other, rather than their usual counterpart. This creates mutations. Generally speaking, these are mutated genes, and they cause the cells to either undergo apoptosis, be destroyed by the immune system, and in some cases, generally most of the time, it can be fixed. If it can't, apoptosis or immunological destruction occurs. The apoptotic cells are the first to be aware of this, as they make up the majority of the cells that we need to talk about. The cells die, and their death leads to release of chemical signals called cytokines. The signals are what cause the swelling and the redness we recognize as the first signs of sunburn. The chemicals also have another job. They tell the body to begin clearing out the debris from the cell death and bring in immune cells to remove bigger material and promote recovery. Later, these signals will motivate healing processes, and the whole thing is kicked off by how UV light damages a small, single piece of RNA called U1. At first, all you see are the signs of damaged cells. This is the swelling, redness and pain. All of this stems from cell death and damage. Those cells that are damaged beyond repair will be removed later on as peeling skin. Let's begin with what happens at a chemical signaling level. That is the cytokine signals that are released. From these, we begin to see some of the more obvious and painful changes, the first of which is swelling. Swelling is a process properly called edema. That is the enlarging of the blood vessels to allow immune cells and plasma out, while still keeping most of the red blood cells in the blood vessel. When the damage is extensive and deep, the amount of fluid can cause blisters to develop. This is when the serum or plasma from the blood that comes out during edema reaches the surfaces of the skin after passing through the different layers of the dermis. That is why blisters are filled with a clear fluid. It's either going to be plasma, serum, or lymph. Another effect of the dilation of blood vessels this way is to increase blood flow. Increasing the blood flow allows for the movement of materials into the site of injury and outflow of waste material. It's very similar to what happens when you blush. In fact, that is one of the reasons why the area turns red. There is an increase in red blood cells moving through the area. The other advantages to increasing blood flow is you can get more cells coming in, notably immune cells to help with patching up the damaged area of your body. More blood flow also means more nutrition, more oxygen, and so on. All of the essential things for damage. This is also why the site feels warm if not hot. That heat also helps to facilitate the body's metabolic processes to repair damage. That in turn also adds to the warmth of the site. The next stage is increase in heat, and it's not an increase in heat in terms of that site in the body has a measurable increase in heat, but an increase in heat sensation. This occurs as a result of prostanoids and bradykinins. They increase sensitivity to heat. They do this by interfering with one of the receptors associated with the nervous system. It's a heat receptor called TRPV1. It lowers activation from 43 degrees Celsius to 29 degrees Celsius, or for those of you who insist upon barbaric numbers, 109 degrees Fahrenheit to 85 degrees Fahrenheit. Other release signals can also interfere with pain receptors, and this is through the production of a protein called CXCL5. When this binds to parts of the nerve receptors, it can cause the sensation of pain, and this is on top of the other effects, such as increased edema pressing on nerves. In collection, all of these effects cause an increase in pain, the increase in blood flow that you'll observe with the coloration, blisters to develop through edema, and in some cases, it also promotes the destruction of cells in the local area that may have either been damaged due to UV radiation, the presence of the chemical signals from those cells that have died, and other phenomena that are biologically necessary to try and contain sites of injury. It's almost like trying to excise the area that's been infected by putting a fence around it of cells that have been destroyed or damaged. Once the immune system comes in and starts cleaning it up, it works its way in, starting with those cells that haven't been damaged but are in the catchment area of this site of injury. As the site of injury begins to heal, the skin will flake off as new skin comes to the surface, and both mechanical and environmental factors wear away damaged tissue. These are those bits of skin that you would otherwise lose every day on a very large scale, but unnoticeably. A difference with this is that it occurs in a much shorter time frame to normal. Sunburn is something that can be easily avoided through clothing that directly and physically blocks UVB, sunscreen to chemically block UVB, and avoiding the worst levels of UVB by staying inside during the peak periods of 10 AM to 4 PM. Outside of this, a little bit of sunlight is good. Too much is bad, and now you know why. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions that you have below.